So yesterday we were discussing about the IPsec protocol, where we were discussing the AH and ESP. So I told you AH provides only authentication, whereas ESP provides optional authentication and confidentiality. That means if I want ESP, I can use it for to provide authentication and confidentiality, or only confidentiality. We discussed about AH authentication protocol uses a header known as AH header, where we discussed the reason for using next header, because AH header is placed between IP header and TCP or UDP header, which is transport header. Okay, that is the reason why the AH should tell which is the next header, whether it is TCP or UDP. That's what next header. Payload length will tell you the payload, which usually consists of the data as well as TCP or UDP header. And the remaining 16 bits are unused. Then 32 bit is SPI, security parameter index, which is a unique identifier for identifying a security association. Then sequence number is used to prevent replay attacks, which is a 32 bit number. So next, HMAC is HashMAC message authentication code that uses a hash functions like MD5 or SHA1, which is used to provide authentication. So HMAC is used to provide the authentication. Since AH protocol is to provide authentication, in AH header, the field that is used to provide authentication is HMAC. Okay. So in the coming slides, we will see where AH will be placed, and we will see it. Next, let's go for ESP header. Coming for ESP, in ESP protocol provides both authentication and confidentiality. That is the reason why it should have more fields. Here, note the point that unlike AH header, ESP has both header as well as trailer. So it has both header as well as trailer. Okay, the first field in ESP header is similarly to AH header SPI, security parameter index, to identify security associations and 32-bit sequence number. So then followed by transport header and payload, that means TCP or UDP header. So this part SPI and sequence number are part of ESP header. Then the transport header like TCP or UDP header followed by payload, which is the data. Then padding. Padding is done in order to make the data to the block size of 32 bit, because it should be a multiple of 32 bit. That's why padding is done. Then similarly padding is continued here. Then pad length is specified. We need to tell which is the actual data and which is the padded bit. That's why padding length is specified in between pad length. So next header, similar to next header in AH, ESP also will have next header followed by HMAC. So this part actually forms the ESP trailer, where next header, pad length and HMAC actually forms the ESP trailer. So ESP has both header and trailer, whereas AH protocol has only header. Okay, now let's discuss in detail. So as I told, let's now discuss AH authentication protocol, header protocol. See, authentication protocol provides only authentication, as I told you. And where AH is placed, AH header is placed between IP header and TCP header. If you have seen the packet format, you will have IP header, next TCP or UDP header, then the payload will be there. So AH will be placed between IP header and TCP header. So IPsec supports MAC. MAC stands for Message Authentication Code, that provides authentication that will prove that who is the sender based on MD5 or SHA1 algorithm. Okay. So you can use MD5 or SHA algorithm. They are hash functions that are popular hash functions. So MAC in IPsec, keep that in mind that MD5 in chapter in module 2, you should have discussed about MD5 and SHA1. MD5 is a hash function where the hash value, that is output of MD5, is 128 bits, and the output of SHA1 algorithm is 160 bits. So So MD5 is 128 bits, SHA1 is 160 bits, 160. So, but MAC in IPsec is only 96 bits. That means the MAC message authentication code used in IPsec is only 96 bits. Then what about MD5 is 128 and what about SHA1 is 160 bits? What about the remaining of the 96 bits? So only 96 most significant bits are of the computed MAC are actually transmitted. The remaining bits are ignored. Okay, use whichever hash function. So the remaining bits will be ignored. Only the most significant bit, MSB bit of 96 bits will be used. So integrity check in AH is computed using part of IP header like source IP address and destination IP address. Say integrity check, AH actually does integrity check or it computes the integrity using parts of IP address like source IP address and destination. In IP header, so there are many fields. Most important fields is source IP address and destination IP address. So which are needed to tell who is the sender and who is the receiver. For authentication purpose, IP address will be used. If someone can modify the IP address, so that is the reason the MAC of the source and the destination IP address is computed and it is verified at the receiving side. So if someone modifies the IP address, so there will be no authentication because the integrity check at the receiving end will fail. Okay. The next point is some of the mutable parts of IP header like TTL, type of service and header checksum fields are zeroed. That means they are made as zero before computing HMAC. So HMAC is computed only for IP header fields like source IP address and destination fields. Some mutable parts. Mutable parts means the fields that will be modified in every op of a routing like TTL, type of service and other checksum fields. If you have forgotten that, so let me show you so the different fields. See, this is IP header. If you see IP header, there is a field like time to leave which acts as an op counter that will be decremented by 1 in every op. Okay, and header checksum also will be recomputed since time to leave is decremented by 1. The header changes, so header checksum also should be computed in every op or every router. So that's why time to leave and header checksum are actually two mutable fields. That means the fields that will be modified in every op of routing. Okay, so that means so to compute HMAC only source and source IP address and destination IP address will be used to compute HMAC, whereas time to leave, so header checksum, such fields will be made as zeros. So next is SPI, which is a 32-bit, which is, as I told you earlier, it is used to identify a security parameter index of 32 is used to identify a security association. It is used to uniquely identify a security association. Okay. The next is sequence number is 32-bit that is used to protect against replay attacks. So sequence number is used to prevent or protect against replay attacks. So this is very briefly about authentication header protocol or AH protocol. See, IPsec is a very complex protocol. Full details are not studied in our curriculum. Only the main points are discussed very briefly. Okay. So to note that, so to summarize, AH provides authentication and the security association is identified by 32-bit SPI and HMAC is used to provide authentication that uses source and destination IP address, whereas the remaining fields like type of service, time to leave, such mutable fields will be made as zero and then we will compute HMAC. Okay, and sequence number is used to prevent replay attacks. And note the point that so MAC, that is HMAC, in IPsec uses only most significant 96 bits, the remaining bits. The remaining bit means if we are using MD5, 128 means 128 minus 96. So which is the remaining 32 bits are left out. Similarly, if we are using SHA where it uses 160 bit as max, so 160 bit minus 96 means the remaining 64 bits are left out, only the most significant 96 bits will be. So this is how the protocol provides authentication. Now let's go and see very briefly about ESP protocol. Encapsulating security protocol, as I told you, provides both authentication and confidentiality. So authentication, it will prove that who is the sender and receiver, and confidentiality will provide the privacy, that means the payload, no one can read the data that is being transferred over the internet. So that is done by using encryption. Okay. Next, other point in ESP is padding is added to the length of the encrypted payload is multiple of block size. Usually we saw it in the previous slide that in before ESP trailer there was padding done. Why we need to do the padding? Because we need to make the payload to multiple of block size. Here the block size is actually 32 bit. Okay, or it depends on the algorithm. If the given encryption algorithm is a block size of 64 bit, it will make the padding to be multiple of 64 bit. Okay. So what is the purpose of padding? As I told you in the earlier classes, padding not only helps to make the block size to be the payload to be the multiple of block size, but also it helps traffic confidentiality. That means it helps in hiding the actual length of data. When we transfer the data, we should never reveal what should be the actual length. That is the one reason why padding is done. So if you are sending 60 bytes, if you do 40 bytes of padding, then the attacker will feel that 100 bytes of data is being transmitted, but only 60 bytes of data is being transmitted. The remaining 40 bytes is actually padded. Okay. So that means padding is usually done when encryption option is turned on in ESP. When encryption option is turned on, when ESP is used to provide confidentiality. Confidentiality means by encrypting. So if you are using ESP for only authentication, then we don't use encryption. So that's what padding is done only when you use confidentiality. That means when we use encryption, the padding will be used. So okay, now let us see where AH and ESP header will be placed in the IP packet and how the position of these headers will be in the two modes, which is the transport mode and the tunnel mode. So next slide we are going to see it. So IPsec tunnel versus transport mode. Now, what is this tunnel mode versus transport mode? The concept is simple. So IPsec works in two modes, transport and tunnel mode. Let us see what is transport mode. In transport mode, only transport header and transport payload are protected. That means you have a packet where IP header is there, TCP or UDP header is there, followed by the payload, which is the data. So in transport mode, only TCP header and transport payload, which is the payload, is protected. In tunnel mode, entire IP header is protected. So that means if you are not sure, let me make you clear. So assume, so this is a packet, so which consists of IP header, so followed by the transport layer header like TCP, or if the application is using TCP, or it may be UDP if it is using, and this is your payload. So now, so what is this transport mode? So I will write it shortly as transport mode. In transport mode, only protection is done for this TCP header and payload. So what is tunnel mode? In tunnel mode, so protection is provided for the entire packet. So protection is provided for IP, the TCP header, and the payload. Let me write it as PL payload. So here protection is provided for the entire packet. So this is the difference between the transport mode and tunnel mode. So in transport mode only security is provided by the TCP payload, that is the TCP header and the payload, whereas in tunnel mode entire IP is encapsulated, that is placed within another IP header. So that's why the original IP packet, which consists of IP header, the TCP header and payload, are protected. So okay. So that is the difference between the transport model and tunnel mode. We will see that in the coming slide. Okay. In tunnel mode, original IP header is encapsulated within a large packet containing IPsec header and extra IP header. That means in tunnel mode, the original packet is encapsulated within the outer IP packet. That means there will be two IP headers there. One is the original IP header. The other one is the external or the outer IP header will be there. That is used for routing. Since the original IP header along with TCP and payload is encrypted, so you can't, since IP header is encrypted, original IP header is encrypted, you can't encrypt, you can't route the packets because router can't see the encrypted IP header. That's why new IP header will be added in tunnel mode. So as I told you, outer IP header is used for routing. The next point is ESP in tunnel mode. When encryption is turned on, that means when confidentiality is used, provided limited traffic confidentiality. ESP in tunnel mode provides what? Limited traffic confidentiality. That means it provides traffic confidentiality. That means it won't reveal who is the actual sender and who is the actual receiver. So of course it will reveal which is the sending network and which is the receiving network, but which is the sending host and which is the receiving host is not revealed. That's why it is actually known as limited traffic flow confidentiality. Okay. Coming slide will make you clear that. So this is what IPsec transport mode is. See, we are discussing here transport mode, AH and ESP. So next we will discuss tunnel mode. There we will see AH and ESP. See, if you see transport mode, IPsec transport mode, this is AH, as I specified here AH. Here IP header is there, transport header is there. Between IP header and transport header, AH header is placed. Naturally, after transport header, there is transport payload. What does AH provides? AH provides authentication. For what part? This is the scope of authentication. For the payload, for the transport header and AH header, so this is the scope of authentication. That means this part, AH transport and header and transport payload, it provides authentication. That means receiver can know that who is the actual sender of AH header, transport header and transport payload. But no authentication, not the point in transport mode, no authentication is provided for this. Of course, you may be knowing that the IP header is modified by someone, so definitely it can be verified by the receiver. How? Because the IP header contains source IP address and destination IP address. Using those source and destination IP address, we have calculated HMAC in AH header. If someone modifies the source and destination IP address here, then in HMAC we can find out. If we recompute HMAC, it will differ. So there will be no match with HMAC. That's why the receiver can tell that. So this is not the original sender. So it will come to know. Okay. So coming for the transport mode for ESP, this is what ESP. As I told you, ESP uses header as well as trailer. So after IP header, there is ESP header and ESP trailers you can see here. So IP header, ESP header. So see the point, ESP header is placed between IP header and transport header. After transport header, transport payload and ESP trailer. The only difference here is in AH only there is a header, whereas in ESP it uses header which is placed between IP and transport header, and ESP trailer will be placed after the payload, transport payload or the data. So now scope of encryption, that means in transport mode, which are the bits that are encrypted here? Note the point that in transport header, okay, so because ESP provides confidentiality, we should encrypt it. See, in authentication in AH there is no encryption here, whereas here there is encryption because ESP provides both authentication as well as confidentiality. So transport header and transport payload along with the trailer, these are the parts that are encrypted. So that means from transport header to ESP trailer there is confidentiality. Then what is the point that is authenticated? From ESP header to ESP trailer, all these things are authenticated. If you try to understand scope of authentication or scope of encryption, scope of authentication means HBAC is applied to which fields? Here from AH header to transport payload, a HBAC algorithm is applied. Here if we say scope of authentication for ESP header, transport header, payload and ESP header, for all these fields, HBAC algorithm is applied. So this is how the transport mode works. So in IPsec. Next, let's go to tunnel mode. So in tunnel mode, so as I told you earlier, the original IP packet is placed within another IP packet. The reason for doing it is the original IP packet will be keep as it is. So someone can see the source IP and destination IP and come to know who is the sender and who is the receiver. That means traffic flow is revealed. So attacker will come to know who is the sender and who is the receiver. So that is the reason we need to encrypt the IP address, IP header which contains source and destination IP address. If we encrypt the IP header which contains source and destination IP address, the routers in between can't know so where to route the packets because IP header is encrypted. That is the reason why new header will be added. So in tunnel mode, this is AH, outer IP header, which is the new IP header that is computed. You see how it is computed. Inner IP header, between outer IP header and inner IP header, AH header is placed. This is the tunnel mode. See the difference. In the previous transport mode, AH was placed between IP header and transport header, whereas in tunnel mode, the AH header is placed between outer or new IP header and inner IP header. Okay. And scope of authentication is what? From AH header to transport mode, this is the scope of that. These fields are authenticated. So that means these fields are authenticated. So then coming for ESP, so again ESP header is placed between outer IP header and inner IP header. After the transport header, transport player, payload and ESP trailer. And scope of encryption, which is the fields that are encrypted. As I told you earlier, encapsulation of packet is done. That means the original packet is encrypted and placed in a new IP header. So IP header, transport header like TCP and payload are encrypted. That's why that is the scope of encryption. Whereas scope of authentication is not only the IP packet but also the header of the client. Okay. So this is the basic difference between the transport mode and tunnel mode. You are supposed to know the placement of the headers and trailers, whether AH header or ESP header and trailer in tunnel mode and transport mode. That will make you clear actually the difference between the tunnel mode and the transport mode. So now, if you want to be clear, this is use of IPsec in tunnel mode. So use of IPsec in tunnel mode is presented here. So that means how tunnel mode works. So there is this diagram shows you host to host and host to gateway communication. The extraction is done by using following diagram. That is, I told you about traffic confidentiality. how the source and destination, sender and receiver is hidden partially in tunnel mode. We can see this. So if you are not visible, let me enlarge it. See, note the point that A and B are hosts, C and D are gateways. Gateways means they are routers. Assume A, here A is the sender and B is the receiver. See, this is one network, this is the another network, network 1 and network 2, which is connected by internet. So host A, this is host B. Host A is maybe sender, B may be receiver. So we want traffic confidentiality between A and B. That means we don't want to reveal the sender and receiver. So that can be done in these two ways. Say here C is a gateway or a router for network 1 and D is the gateway or router for network 2. So if you see here in case 1, which provides host to gateway tunnel. That means it provides a tunnel between host to the destination gateway. That means it will reveal who is the sender, but it won't reveal who is the destination, which is the destination host. Here inner IP contains, usually this is the IP packet, inner IP contains what? Source is A, so source is equal to A, destination is what? B, so destination is equal to B. So this is IP header, original IP, TCP header and payload. So someone intercept this, they can know who is the sender and receiver. That's why the IP header along with the payload is encrypted. New or outer IP header is added which contains source as A. Why is source as A? Because it is host to gateway tunnel. So I will give the source as A, sending host, and destination as D. So destination as D, not B. D is a gateway or a router. So this is sent to D, and it is the responsibility of the D, which is gateway or router, to route the packets to B. So that's why someone intercept the packet in the internet. By seeing this, they will come to know the packet is going from source A, host A to the network 2. But it won't know there may be thousands of machines on network 2, but the intruder won't be able to know who is the actual recipient. Okay, so host to gateway tunnel will provide what? So limited traffic flow confidentiality. It will reveal who is the sending host, but it won't reveal which is the receiving host. It will only tell which is the receiving network. Okay, so coming for the second point, which is case 2, which is gateway to gateway tunnel. See, gateway to gateway tunnel means only the sending and receiving network is revealed to intruder. So not the sending and receiving host is never revealed. Here, the inner IP contains source as A, destination IP address as B. But outer IP will contain what? When a packet comes to this gateway C, so it will replace that source as C itself and destination as D, which is the network to gateway. So someone intercept and see this, they will come to know source is C, which is the router here, and destination D is another router. So that means some intruder will come to know the packet is going from machine with IP address C and IP address D. But the actual communication is between A and B. This is not revealed because this part is encrypted. Okay. So that means this is what I told you, limited traffic confidentiality. So here you may be wondering how can the C and D come to know where to deliver the packets, whether the C actually and D gateway should maintain, they should have implemented IP set, they should maintain a table. So when a packet comes from A, it will replace that with C and send it to the destination D instead of B. Similarly, D will translate that address, remove the D IP address and place the B's IP address, so it will go to the destination B. So here translation of converting the original address of A and B will be done by the router C and D. Okay, so this is how actually our IPsec works in tunnel mode. This is what I told you about limited traffic flow confidentiality. Okay, next, what is the problem with IPsec? What is the problem with IPsec? So the main problem with IPsec is it is incompatible with NAT, Network Address Translation. Probably in the previous semester when you discussed the networking, probably you might have studied about NAT, which is Network Address Translation. So how many of you are aware of NAT? Any answers? No. So I don't know whether you people are listening or not. Hello? Hello?
Yes, sir.
Yes, sir.
So people have studied about NAT, Network Address Translation. Why Network Address Translation is used? You people have at least heard of the private IP address and public IP address. Okay. Okay. So let me try to explain that without knowing what is a NAT. I can't go with why IPsec is not compatible with NAT. Okay. So now let us try to explain what is NAT. So what is this NAT? See, you people should know that there are two types of address. Okay, before that, let me tell you, IP protocol, there are two versions. So that is V4, version 4, and the second one is version 6, IPv4 and IPv6. So what is the difference? There are a lot of difference, but note the point that in IPv4 it uses 32-bit address, whereas IPv6 is a newer version that uses 128-bit address. So the point here is though IPv6 is there, it's more than 25 years old, people are still using IPv4 address, and the number of hosts that can be used is always less than 2 to the power of 32. The number of IP address we can have in the world, not even 2 to the power of 32, because some of the IP address here is used for research and experimental purpose. Some of them are reserved for private addresses. So it will be usually less than 2 to the power of 32, which is not sufficient to the current explosion of internet. So that means 25 years back itself people know that we'll be running out of IP address. That's why the temporary solution was provided. Okay. Anyway, now the point to say here is there are two types of IP address. So private address, so private IP, so private IP and public IP, which is globally used IP. So public IP. See, there are some range of IP address which are reserved. Anyone can use this, any network can use this IP address. For example, you may be wondering what is that? We especially use in our college all the machines, and majority of the machines use it. For example, an address like 192.168 dot something. Okay, let me not go into x dot y. Here x and y are any numbers between 0 to 255, because 8-bit numbers can have a range of 0 to 255. So any address, usually any address starting with this address, okay, 10 dot, so x dot y dot z, some address starting with 10, they are actually private IP address. So what is private address? Any private network. For example, a LAN in SDCIT can use a private IP address with these kind of IP address. Similarly, many organization companies, many colleges can use the same IP address. But only limitation of private IP is we can never allow this packet to contain this private IP address on the internet. On the internet, only public IP address can be used. So public IP address can be anything like, so for example, you are having some address 117.10.5.5.3. Okay, this is public IP. So you should have an IP address like this. If you have named IP address like this, so this kind of IP address should be converted to this address. Because the private IP, all the networks will have the same IP address. If you put a packet into the internet with that private IP, so definitely all the packets will have the same IP address and you can't route the packets. So the only condition is private IP. You can configure any computer in a network with private IP address, but if you are connecting to the internet, that private IP address should be converted to public IP address. Okay. So now the point is how NAT works. Let me show you. So this is a network, organization network. Let us say there is a router here, and router R in this is our college network. So there may be many computers here present in our organization. Multiple machines are present. So assume there are 500 machines present. So if I want to go for public IP address, I assume there are 500 machines here. So 500 public IP, because IPv4 has only less number of IP address, we won't get it, it will be costlier. So everyone tries to buy this address, we will run out of IPv4 address. That's why, so we are having 500 machines, what we do, we will configure them with a private IP address. Okay, the next point is, all these machines, but I want all the students in my network to connect to the internet. So we want to allow the students to connect to the internet. So that means their packet should be sent to this internet. But internet, the packet should contain what? Only the public address. So the point here is, I have 500 machines. So I can't buy 500 public address because we are running out of IP address. So what we do is, he will buy only one public address. One public address we will have, which will be configured in the router given by internet service provider. So the router will have public address. When a packet comes from all these machines to the router will do what? Convert this respective, it will maintain. So this router will have a software built within it, which is a software known as NAT software. The router will have a NAT software which performs network address translation. What does it do? It will convert the private address to public address. And from the router, packets enter the internet, and router, all the packets originating from our network, all the 500 machines sending packet will contain the same IP address which will be routed in the packet. So that will be sent in this direction. What if the packet comes in from the internet? The packet may come to the router NAT with the NAT router IP address, which is a public address. From NAT, it is the responsibility of the router using a NAT table, network address translation table. It will convert and it will find out who is the destination node and send that. So this concept, we call it as network address translation. So I think everyone understood the concept of NAT. Okay. So note the point that here, the original private IP will be replaced by what? By a public IP. That means, keep a point that the original IP address will be replaced. Original IP address is the private IP address will be replaced by public IP if you are using NAT. And almost all the networks in the world which are using IPv4 are using NAT. It is network address translation because it minimizes the number of public IP address that we use. See, in this case, if we have not used NAT, how many IP addresses, public IP addresses I needed to have? 500 public IP addresses we used to have, but right now, using only one public IP, we are able to manage it. That means, of course, it will be a slower, the internet will be slower because translation is to be done, but that's the way to go. That's all the people all over the world, the networks use NAT. So now, let's go to this slide. So incompatibility, that means if you are using IPsec, it is not compatible with NAT. Why it is, you will see. AH in transport mode, packet has only one IP header. In AH transport mode, we have only one IP header. Only in tunnel mode, we have two inner IP and outer IP header. Okay. In transport mode, only one IP header. Source IP address is translated. So MAC includes source IP address or message integrity files. So that means in NAT, what does it do? Source IP address is transmitted. Source IP address is there. The private IP address will be converted to public IP address. But MAC is calculated based on what? Based on source IP address, which is the private IP address. So when you translate it to the source IP address is translated to public IP address, what happens? The MAC will change. That means at the receiving side, if someone computes the MAC or message authentication code will be different, so then naturally it will fail. So that means NAT is not compatible with the IPsec authentication header in transport. Now let us go to tunnel mode, AH in tunnel mode. The IP address in outer IP address. So here we have two tunnel mode, two IP address, outer IP header and inner. The IP address in outer IP address is also translated. Inner IP address is encrypted. The outer IP header is translated. Translated from what? Private IP address to public IP address. So naturally the MAC includes source IP address here. Message authentication includes source IP address, so message integrity again. Okay. So here integrity is checked on only one header. That header IP address is modified, so integrity fails. Here the inner IP header is encrypted, outer IP header integrity check is done. So it fails because NAT will modify the IP address from private to public. So that means AH, transport and tunnel mode won't work if you are using NAT. So IPsec AH authentication header protocol in transport mode or tunnel mode won't work with NAT or network address translation. So now let's go to ESP in transport mode. The scope of IP header does not fall within the scope of NAT, but the TCP checksum fails. The scope of IP header does not fall within the scope of NAT. In transport mode, the scope of original IP header, we don't calculate MAC. Why we don't calculate MAC? Because the original IP header is encrypted. We don't calculate the MAC for that. We calculate the MAC for outer IP header. That is the result. The scope of IP header does not fall within the scope of MAC. So TCP checksum fails. One TCP checksum fails. The TCP checksum that is done by TCP header fails because NAT translates source IP address and TCP checksum user source and destination IP address is used in TCP checksum. That's why the TCP checksum fails. So TCP checksum can be recomputed in encryption not used by message integrity fails. That means TCP checksum can't be recomputed because TCP checksum is in TCP header which is encrypted. So that's why you can't go for message integrity. So message integrity is right. That means the ESP in transport mode also fails in IPsec if you are using network address. If we are using network address translation. Then finally let's go for the tunnel mode. ESP in tunnel. Only IPsec mode to coexist. This is the only mode that can coexist with NAT. Why? You see, IP source address get translated in our outer IP address. This is neither covered by IPsec, NAT, nor does it fall within this scope. Here, in tunnel mode, only the outer IP address which is the outer IP address which contains the resources get translated to private address to public IP address. So because the outer IP address is not authenticated, nor it is fallen into the integrity, that means the outer IP address neither covered by IPsec fall within the scope of the terms of this tunnel mode box. So you can see this here. Previously, you can see here. So the outer IP address does not fall within the scope of encryption or scope of authentication. Scope of encryption or scope of authentication. The outer IP address is there. So that is the reason why. So ESP internal mode will work. That means if you are doing network address translation only, ESP in tunnel mode will work, whereas ASP in transport mode, ASP in tunnel mode, and ESP in transport mode doesn't work. Okay, that actually gives you a brief introduction to IPsec. Next is the point. We have discussed about IPsec. The very point we discussed in IPsec is we need to establish a security association. What is security association? It's the one-way association between the communication entity. What does it contain? Security association contains various parameters like SPI. The main purpose of security association is it tells which is the encryption algorithm used, which is the authentication algorithm used, what are the keys. How do you exchange these information? That means we are using some encryption algorithm, but it uses a key. How do you exchange a key between the communication entities? For that itself, we have a protocol. We have a protocol known as IKE protocol, Internet Key Exchange Protocol. Keep this in point. This is a protocol used by IPsec to establish a security association. So IP protocol is used to establish a security association between two parties that wish to communicate securely. So that means IPsec uses IKE for exchanging the keys and encryption algorithms to use a security association. So note that as I told you earlier, the same includes cryptographic algorithms and key used for encryption and decryption. IPsec is a network layer protocol, whereas IKE is an application layer protocol. Keep that in mind. IPsec is a network or internet layer protocol used as a network layer. IKE is used by what? It's an application layer protocol that uses transport protocol UDP with the well of it's a client and server application which is at the application layer will use IKE protocol, not the network layer. And IKE protocol uses not TCP, it uses UDP and it uses a well-known port number 500. Okay. So keep that in mind. So IPsec is a complex protocol that uses many other protocols. One such protocol the IPsec uses is IKE, Internet Key Exchange Protocol. And what is this IKE? IKE itself is derived from the other two protocols, which is ISA-KMP, Internet Security Association and Key Management Protocol, and Oak-Lake Key Determination Protocol. So ISKMP defines format of various entities like digital signature and digital certificate. ISKMP actually specifies digital signature and digital certificate. Oak-Lake Key Determination Protocol will do what? The kind of information to be exchanged in each message that is part of IKE. So the actual key is exchanged by using only the Oak-Lake Key Determination Protocol. So to say in short, IPsec uses IKE for security association, and IKE is derived from ISA-KMP and Oak-Lake Key Determination Protocol. So we are supposed to discuss IKE, Internet Key Exchange Protocol. How does IKE helps us to exchange keys between the sender and the receiver? So that is the topic that we need to study. So I will stop at this because it takes a lot of time to go for IKE protocol. I want you people to ask any doubts, so you can clarify your doubts. Any doubts? There is no voice from your side.
No, sir.
So if you have any doubts, you can ask it. What about the quality of the audio and video with Cisco Webex? Since I am using Cisco Webex, are you able to see the presentation properly?
Yes, sir.
Huh?
Yes, sir.
Yes, sir.
So no problem with it. So okay, inform there are only few students attending it. HOD has clearly specified and the university has clearly specified the online classes to be conducted and attendance should be maintained by recording your video conference. See, some of you are not used the names properly. Some of you are displaying your mobile phone names and other things. So next time when you connect it by tomorrow, you change your name to your name with your original initials so that I will be able to record. So who are the actual participants? So that I can see. Okay. So if it's good, next tomorrow we will meet at the same time, 11 o'clock. We will try to continue. So if those who have not attended, you share the link to the students. Okay, I will again put it in the WhatsApp group. So let's meet tomorrow at 11 o'clock. Thank you.
Sir,
Thanks, sir.
Yeah.
The transport mode provides a protection only for TCP and payload. Why it doesn't provide the protection for IP, sir?
Just a minute. So you are asking about transport not provide.
It provides protection only for TCP and payload, and why it doesn't provide the protection for IP?
See, that is the necessity, not non-necessity. That's what. See, we are providing flexibility to the user. That's what IPsec provides. See, IP security is not provided for IP header. Reason is, I don't need traffic confidentiality. Assume my only data. I am sending some data to the receiver. My only data should not be read by anyone. Let them know who is the sender and let them know who is the receiver. Let me reveal it. I don't want it. In such case, we can go for transport mode. The transport mode header is not encrypted because a user using that don't need it. Because assume I am communicating with you people using some video conferencing. So my encryption video conferencing may be encrypted, but I don't want to reveal I am the teacher, you are the students. Let's not hide it. What is the necessity for doing that? So definitely I may use a transport mode. Okay. The transport mode, IPsec provides flexibility. If you want both data confidentiality and traffic confidentiality, go for tunnel mode. If you want only data confidentiality, use transport mode. Okay, the burden of encrypting the IP header will be removed in transport mode. That is the reason we are using transport mode. Hope you got the point.
Yes, sir.
Okay, we'll stop it for tomorrow. So tomorrow at the same time, 11 o'clock, using the same Cisco web meeting. Thank you.
Thank you, sir.
Okay, sir.